pass you over to Mohsen first. But yeah, thank you.
Sure. Hello, everyone. My name is Mohsen Mosle. I'm a senior lecturer at the University of Exeter Business School. I'm very excited to have today Professor David Garcia. So David studied computer science in Spain and Switzerland, where he also did his PhD and postdoc at ETH Zurich. He focused on computational social science, especially on analysis of social media data with computational models and agent-based models. He then moved to Australia for his first project as a PI, and since 2022, he's been a full professor at the Department of Political Science at the University of Konstanz. I'm very excited to have David here. Beyond anything else, I'm personally very interested in his research in computational social science, so I'm very excited to and looking forward to hear his talk. Without further ado, please take it away, David. Thanks so much.
Thank you. Thanks a lot for the invitation, Mohsen. The appreciation is mutual. Also, when I saw that you wanted to listen to me, I was very, very happy to also establish some contact. Hopefully, we can do the same, but the other way around. You can come to talk with us at some point. I'm sorry I cannot travel. I have a small toddler I'm responsible for, and it's probably complicated. But I hope that online works well for today. Let me share my screen so you can see what I see. Yeah. Good. It all works, right? You still see my slides. Yes. Thank you. So also a note on everything I will present is that you can find the slides online in the garcia.eu/Exeter 2024. And so if you want to go back and forth, you are free to do it on an HTML version of the slides. And yeah, today I will talk about what I do to study emotions with social media data, especially because they help to bridge levels of analysis of emotions between individuals and collectives. And first, a bit of introduction. Everything I do is with a lab. Of course, I'm never really alone. I'm now in Konstanz, but I still have members of my lab in TU Graz, where I was right before, and at the Complexity Science Hub in Vienna. My team is very multidisciplinary, so I have psychologists, especially the ones in Vienna, like Hannah Metzler, or Alina Herderich, that is right now in visiting Harvard, but she does her PhD in TU Graz. We also have some computer scientists like Indira Sen and Segun Arroyekun that join me in Konstanz. And other people from more physics or systems perspective, like Jana Lasser, that is about to start as full professor in Uni Graz in May, or Emma Fraxonet, that also works with me, and she has visited us in Vienna and Konstanz. And everything I will present has been mostly funded by the Vienna Science and Technology Fund that has funded two of my bigger research projects, and in the ERC, by the ERC, in a project in collaboration with Steve Lewandowski, that is also with us today. And what we do in my lab is that we try to study emotions with these computational methods across scales. That's what we call computational affective science. And actually, what I will talk about today is examples of how do we do this. It's not a full research plan, but will present a couple of papers in which we are trying to develop and validate computational methods to study emotions. We have other research topics. We study, for example, polarization dynamics, in particular how opinion or issue alignment emerges in a society, and how that can be explained with agent-based models, especially building on cognitive science principles. And then we also study information disorders, mostly misinformation, but also other issues related to data and privacy online. This started mostly because from all of my grants in the last 5 years, the ones that contain the word misinformation got granted, and the ones that did not contain the word misinformation did not get granted. But it's a good way to acknowledge that it's a very important topic, and more of my research is also dealing with basically how social sciences can help us to understand the meaning and the use of these new kind of ICT and social media technologies we have. And among those topics of issues with information is what I call complex privacy, and how the information that other people share can be telling things about ourselves, to the extent that maybe without having an account on an online platform, the owners of the platform can still make inferences on you based on the data that your friends share there. That's another research line that sadly I won't have time to talk about today, but if anybody's interested, also feel free to send me an email, and I'm happy to always talk about those topics. So in this idea of computational affective science that I'll talk about today, stems from the idea of studying new digital traces of human behavior from social media, and that's part of what often is called computational social science or social data science, as kind of an interdisciplinary field where you are mixing methods from computer science with other principles and models from math and statistics, and you apply them to the behavioral and social sciences. So the main idea is that compared to traditional research, that will be this green area here, where you apply statistics to the social sciences, in this first age of research, we were trying to make sound inferences from too little data. Data was expensive and complicated to come by, and we wanted to make sure that what we could conclude was what we could do with that kind of data. But now with this new digitization of human behavior is giving us another type of data, and the challenge there for data science is a bit different, is making meaningful inferences from too much data. And the challenge is both an opportunity and a challenge, but it's different. Now you need to first take into account methods for collection of data that are different, methods for the analysis of data like NLP that are also different, and also what they tell you is just not the typical statistical test, but they can tell you other things that will be significant and robust, but maybe they don't make sense. And that's where you especially need the behavioral and the social sciences. So I've seen Venn diagrams like this one a lot of times, and that's where there's this kind of unicorn in the middle of some kind of magical, mythical character that is able to do all these three disciplines. And I've seen like 20 versions of this Venn diagram, and I never really knew how to do this, not how to be that unicorn. Over time, I found kind of my own recipe, but it's not by no means universal. But I think it's a boring picture, but more descriptive of what I try to do. Is that I use computer science methods, that's why it's pink, that I analyze large-scale digital traces, mostly from social media, but not necessarily. I've also worked on data from apps, for example, mobile apps or search data, so things that are digitized data repositories of human behavior, and that we collect with computer science methods. But once we analyze that data, we get, for example, a variable that we measure over time, like sentiment on tweets. What it means is something that requires work. Whether it, for example, agrees or disagrees with other methods is something that we need to do. It's not instantly evident from the data. So there is where I try to do things like validation against survey data, where we can triangulate what we measure online with what we measure in a survey, sometimes at the individual level, sometimes at the whole societal level. But the idea to see whether different methods agree or disagree, and when they disagree, also what can we find out? But as a way to be able to compare with other methodologies for which we know better their properties than this new kind of digital data. But even when I do that, and then you get like now a validated metric, still what it means for human behavior, what can we do with that insight, is something that requires more than just mere observation. Most often, because in the social sciences, we worry about causation, in particular, how a policy would influence the behavior of an individual or a society. And to be able to make use of that kind of now new, let's say, validated data, we need something else, a model that can explain what we see in the wild, dirty world in terms of behaviors that we're able to, for example, intervene on or regulate or motivate in some way. And that is where I use computational modeling, and my favorite math and statistics methodology, more taken from complexity science. Often it's called agent-based modeling. And the idea is to have a simplified version of an agent that is able to explain some stylized facts of the macroscopic behavior that we see in these digital traces. But often these kind of models are built on very simplifying assumptions that might not be realistic. And that is where I try to especially work on control experiments that can validate those assumptions of the models and close kind of a loop between micro level human behavior and like macro level observable behavior online. This is too much for one paper, so to speak, and even it's too much for one talk like today. So often I can present parts of it, And today I will focus mostly on the first part of on measurement and validation to make sure that we know what we're measuring and what it means. And then for other days or for other my papers, you can see how we use agent-based models to reproduce that. So I'll focus mostly on what people will call the data science part of this pipeline, while the other one is more the computational agent-based modeling part. And so this is a bit my struggle to try to make sense of computational social science, also as a computer scientist in a political science faculty, where it's very nice and very welcome by political scientists, but often just developing methods is not enough. They also need explanations on what the methods actually measure and what can they be used for. So today I will present two of these kinds of works. One is the validation of the promise of social media macroscopes of emotions, in the sense of measuring emotions at large scale in a society and how these change over time. And then in the second part, I will present one of our latest works on detecting individual emotions at the individual level on social media and trying to have a method that tells us how people feel rather than just an overall sentiment measurement of a piece of text. And let's go with the first. So why am I talking about these macroscopes? Is that there's been research that has been using large-scale social media data to measure some emotional state of a society over time and at a very large scale. Keep in mind that you're able to measure the emotions of the whole society at some point, and then you can make a fraction of how many people are angry right now. And so one of the early promises of social media was to precisely have this, to be able to say, if social media represents a society, which is part of the question, how many people are expressing a particular emotion at this point in time. This is what I call macroscopes of emotions, in the sense that the microscope is allowing you to see things at a smaller scale as your scale, things that you cannot see with your naked eye. And the macroscope is the opposite. It's like putting a telescope outside Earth and being able to see everyone and see things that might not be visible from the naked eye on the telescope, something like in a state of people. I think a good example of a macroscope, a traditional macroscope, will be a representative survey. But the promise of social media data is that it can do it at a faster time scale, it can do it for longer periods of time, or it can also maybe measure things that could also be complicated to measure on a survey. And so there's a couple of seminal papers that started this a decade ago. One is this one by Steve Golder and Michael Mason in Science, where they studied with word counting methods over time in Twitter, and they tested, for example, that in the night people express more negative terms than during the day, and that there's oscillations during the week. But the interesting thing is that they use it to test a hypothesis about how changes in day length affect people's mood, that they could test at scale thanks to that data. But it's based on basically word counting and what is the frequency of positive affect and negative affect terms on tweets. The second one is the hedonometer by the team of Peter Dodds and colleagues in Vermont. And there is also based on a dictionary. So you have a list of words with a rating between very negative to very positive in a happiness scale. I think it's from 1 to 9. And then over time on Twitter, you can measure the average happiness or valence of every word said on Twitter on that day. And then have a timeline like this one, in which already the naked eye shows you that this is from the US. Usually July the 4th is one of the happiest days, and then you see Christmas and so on. Things that the calendar can also tell you, but there's also things that the calendar cannot tell you, like the reaction to terrorist attacks or longer trends that happen in the language. And so these methods had a lot of promise, but they also brought a lot of questions. It's like, who is talking on Twitter? Are they actually expressing their emotions? Are you measuring what you think you are measuring? Are you measuring it in a group of people that can tell you something about the rest of the society or about someone in society, but do you know who are you measuring? And what are the properties of this over time? Do you need to, for example, correct it across years or things like that? It was very promising, but brought a lot of open questions about how this works. I think also in previous work, I used this myself. I based on the same assumption when I studied the collective emotions after the terrorist attacks in France in 2015. And this was very similar. So word counting of positive and negative words, or what's related to particular emotion terms on French tweets, and then having that as kind of a signal of the average emotion, so to speak, or the frequency of emotions in a population that is larger. The interest population will be larger than what only uses social media. So this one in particular was testing a hypothesis that links collective emotions as shared emotions that are very strong and last longer for a period of time, which often after a very strong terrorist attack like that one, they are often visible in a society. And there's a theory that hypothesizes that prosocial behavior is linked to the experience of these positive emotions. So at least we saw that the Twitter data does not refute that hypothesis, that there is also an increase over time of prosocial language after the terrorist attacks, and that the people that were involved in that emotional, collective emotion, they have higher frequency of prosocial language for up to 6 months after the attacks. But again, this is building on assuming that Twitter users are useful as a sample to tell something about France. Is assuming that when they express angry words on Twitter, these are about anger, and that they don't, for example, fake being angry without really being angry, or that the people that talk on Twitter are so strange that they react in an emotionally completely different way as the rest of the population. So as an approach that complements a survey, for example, in a period of time when making a survey will be impossible, we cannot go back in time, or often set up a survey right after a terrorist attack, you will need a few days of delay and you cannot get it as it happens. It was a nice way to try something, but not a sufficient one to build a scientific methodology on top. And back then, like 2017 or so, when I was working on this, I was like, okay, I'm worried about it, but I don't see signals that this is terribly wrong. So let's see, maybe someday I managed to test it. But I was still a bit relaxed about it until a paper came out a few years ago, 2020. It's a very nice one by Kokilyak and colleagues, where they do this not over time, but across space, across regions in the US. And they test the correlation between these simple word counting methods in tweets in different regions in the US and Gallup data. So it's a representative survey. They do a very creative way of trying to get smaller regions representative and accurate still. And to be able to get the tweets from that region, the average, for example, happiness, life satisfaction, or reporting of feeling worried or feeling sad, and correlating that with what people write on the tweets. And they found, first of all, the correlations tend to be relatively weak. This is a table of the correlation coefficients across regions. Again, it's like stuck in time. It doesn't look at time differences, but for 1,200 counties, you can measure that correlation. And is agreeing with previous results, but this I would say is one of the most powerful studies that ever tried that. The correlations you get are like something like 0.25 or 0.30 something, but not strong enough for you to say, I can replace the survey with the social media data. It's still very noisy. But the thing that I will find especially worrisome is that in some cases, for example, here, the frequency of positive words was negatively correlated with life satisfaction or with happiness across counties. So taking a method, a word counting method at face value can give you paradoxical results with what you will expect if social media data trivially represents people in the platform. The paper fixes this to a greater extent. They also have a trained model that they can apply to individuals and post-stratify and so on. It's a very good exercise on trying to improve on this. But this brought me the concern of like, how does this play around time? So here comparing well-being or trying to predict well-being from social media text will be a very, I would say, challenging or ambitious task, given that we know that there's so many things that influence well-being at the average scale, given that we know that there's a noisy measurement of well-being and the retest reliability of the satisfaction with life question is not perfect. It's about 0.8, the correlation. So it was very ambitious. I thought maybe over time it's not that ambitious. And then if we have a survey over time and social media data over time, like in the macroscopes I showed you, still captures some variation of the change over time for a particular population after basically this error has been corrected because it's all one place. So this is the design of the study I want to show you today, the first study, which is something I designed when I got tenure because I was ready to take the answer, which could be, David, everything you did is wrong, or it's okay, or it will give me a number on the quality of this methodology. So I pre-registered a study in which I wanted to compare data from Twitter and data from a representative panel from the YouGov UK representative survey that every week asks a number of questions, and among them there's a battery of questions about basic emotions. So these are emotional states, basically asking over this last week, have you experienced sadness, have you experienced being scared, have you experienced being happy, and so on. And there's 12 questions there. And so it's kind of like the reconstruction method that is asking what did you feel over the week. It's complicated. It's better if you can ask what did you feel yesterday or today, but given the resolution they have, they can only get as good as a week based on when people reply the question or not. And the good thing is that it is representative and over time per week, so we can get a timeline of several emotions. And they're the 3 emotions that match a priori with some of the text analysis methods widely used in the literature, is being sad, being scared or anxious, and being happy or experiencing positive emotions. There are others, but they don't match so well what has been developed for NLP. Also often because some emotions are not well expressed in language, like feeling disgust, for example, is one that often is not easy to identify from text, unless someone says very explicitly, I'm disgusted, but anything else makes it very complicated. And so that's kind of I will call it the state of the art or the baseline to compare against. And then what I did is to get data from now the rebranded Crimson Hexagon. It was a company that was collecting the full fire hose of Twitter data. Now it's called Brandwatch. I think it got bought twice since I made this study. And from Crimson Hexagon, you can ask them to give you samples of tweets filtered by location. So they have their own location model and by gender, which I can use to analyze, for example, the text of the tweets or to gather the tweet content and then have a big database of tweets that has been processed by this platform so that I know the location and the gender, and to be able to apply the established methods to see if they agree with the standard survey data. And so basically, Crimson Hexagon can tell me for the UK, these are tweets that have been produced in the UK, and I wanted to know the gender because when looking at data from the UK in particular, more or less the number of users, men and female users, are more or less the same, but the number of tweets produced by male users is substantially larger. They're more active than female users. It might be related to something about the toxicity of Twitter or the exposure that people have there. But when you take it at the tweet level, 2/3 of the tweets in the UK are written by men and 1/3 are written by women. So without considering gender, we'll be weighting double the men on the sample than the women. And I wanted to use this methodology of Crimson Hexagon to have a good and well-validated method for gender detection, so I could rescale the gender and have now a gender rescale weekly index of emotional expression. My first hypothesis was using LINQ, linguistic inquiry and word count. That is just a dictionary of words for the 3 emotions we're talking about. That was what I used in the French terrorist attacks, or what was used also in that science paper. But on top of that, I said, let's also try some more advanced methods, like a Roberta classifier trained against the Seneval dataset that also contains emotions, to see also how different methods will fare against each other. So after doing that, I have another time series that is a gender rescaled weekly index of emotions. And then what I did is to say, okay, when I pre-registered this, there was some data that was historical. I mean, I had a subset of it, but just for sake of the pre-registration, I said, this is something I could have analyzed. It's not a real prediction. So let's call it the historical test. And then there's a future data I hadn't collected yet. So let's call that the prediction part. Which is future data, and then to see how reliable is the correlation that we can measure in the historical part versus the correlation we measure in the prediction part. And methodological comment on this, there's 2 measurements of correlation. One is just a cross-correlation coefficient, like a plain Pearson's correlation between weekly indices. This is often not something that you can use to test causality because the time series both have seasonal effects and trends that influence both. It's not a matter of causation, but they can tell you the simple correlation coefficient, how good is it if you replace one time series for the other, in the sense that if you lose one of them, how badly or how much of the variance could you explain from the other time series without assuming causation, just assuming another measurement method. But to be closer to correct for those kind of non-stationarities, basically because the null causation between them wouldn't be zero. I also applied what is called the trended cross-correlation analysis, that is just the trend in the time series, so making it stationary and then just calculating a correlation coefficient on top. So the results are in detail in this archive preprint I put down there, but I want to walk you through them a little bit. First, this is the plot of sadness on Twitter and YouGov using the Look dictionary for sadness. So in red, you have the time series of this. I mean, I put it scales because they have a slightly different scale, of course, was like a different scale. One thing is expressed, and the other thing is experienced. But when we put them on the same scale, you see that the variation that they have is rather similar. The gray point is the separation between historical and prediction period. So the correlation, the cross correlation between them in the historical period is something like 0.7, and in the prediction period is a bit less, but 0.67. So there's quite a correlation between the expression of sadness on Twitter and the reporting of sadness in a representative survey over time. In particular, you have some spikes here. There's this spike before 2020. It's a bit offset, and I think this is because there was an election there that apparently made a lot of people sad. I think the ones in the UK might be able to tell which one it was. And then the pandemic came, and we see here the spring 2020, the lockdowns create quite an increase in sadness, and then this slowly came down. With the exception of here, you see in red, there's a spike on Twitter that does not appear in the survey, so now here the methods diverge. It's not a lot, the correlation is still high, but it's worth mentioning that here we have the Black Lives Matter events that created a sharing of sadness on Twitter that people did not report in the surveys as really feeling sad. It wasn't above the threshold of sadness to say in a survey, I was feeling sad, but they were expressing sadness on Twitter. So already from the errors, we can tell maybe there's some kind of tweets that we can already tell a priori they are not real expressions of sadness, but some sort of shared sadness, for example, with another country. So then we have a bit of some other pandemic oscillation, of course, but at least the cross correlation between these is rather similar. And when we used other methods, this one is, by the way, this one is with Roberta, but with Luke is very similar. It's like, no, this one is with Luke, but the one with Roberta is very similar. It's like 0.65. So even across methods, this kind of expression of sadness was more or less what we were expecting. The expression of anxiety or compare versus being scared is also rather similar. So we have here is the same time series. Red is Twitter and blue is YouGov. There's the dip of anxiety that happens around Christmas, as one would expect. And then there was this huge spike that was the beginning of the lockdowns. Using both datasets in the YouGov lasts a bit longer than social media, but this is visible in both. And actually, it's interesting here that if you ignore gender in this analysis, we did it because it was part of the pre-registration, the correlations get worse. And then when looking at the data more closely, we see that women report in the survey to have higher levels of anxiety, and they also express more anxiety on Twitter. And so this, if anybody had kids and you had to be at home during the lockdowns, you could relate to this, that it was a very high anxiety period that seemed to have a special load on women in particular. So the correlation over the historical period was very high, 0.78, mostly because of the huge variation that this spike has. If you basically calculate a ranked correlation, it gets weaker, something more realistic, like 0.6. And then after the historical period into the prediction, the correlation is also not zero, but it's not that high, not something like 0.5. So this shows that for periods in which things don't happen, when there is less variation, of course, the correlation gets weaker because there's less of a signal. A measurement like this makes more sense when you're having high variation and big things happen, like a terrorist attack or a lockdown. But if you're only trying to see changes between a normal day and the next day, this is not accurate enough. Even the survey itself is not accurate enough also to measure those changes. No, it gets correlated to a noisier level when big things are not happening. And this one was also similar with the supervised and unsupervised methods. The one that was different was positive expression or joy. For look or word counting, there was no correlation at all between positivity of expression on Twitter and on the survey. This was something that was already starting to be expected by the literature, in the sense that the word list of emotions, of positive emotions in look was pretty unspecific in the sense that it was very long. In defense of Luke, I would say that in the latest version they have, in 22, the word list for positive emotions has become much more precise, and they have another sentiment positivity word list. So with a newer method, might be better. But here I'm showing the comparison with the supervised sentiment analysis method, where it's better than 0. Again, in red you have Twitter, in blue you have YouGov. Here are things you could predict with the calendar, like Christmas, but you have these other dips, like the beginning of the lockdowns, or here is the Black Lives Matter again, that is stronger on Twitter than YouGov. But the correlation is also relatively stable between the historical and the prediction period. So there's correlations of something like 0.6 or so between the methods that one will measure with a survey and one will measure with social media data. And when looking at that, I was wondering, okay, so how high is 0.6? How well will a survey correlate with itself if we have like 2 samples of the same survey? And it's hard because we don't have another YouGov, of course, for the same population and the same question. But in the US, there are concurrent surveys, especially trying to ask regarding vote intentions for the president. And they're a good example of how a subjective question like this, who will you vote for, over weeks, correlates between very different survey companies. And, can you hear me? I can't hear anymore. Yeah, all right. So, when you take those 2 presidential voting intention surveys and measure them over weeks and correlate, you get a correlation of 0.65 in the US. So also they tend to disagree to some extent to the voting outcome, but usually survey data is also not error-free. And something more than 0.6, even to the level of 0.8, will be a bit unrealistic. Now, survey research also has a bit of an error itself. However, I would say that this is showing that social media data is not worthless, at least for checking things over time. It's just that we need validations like this to tell us whether we're in the good direction or not. And in particular, we replicated this at a faster timescale in Austria because the newspaper, The Standard, was asking the same question or a similar question, like, did you experience positive or negative emotions yesterday over a particular period within the pandemic of almost 3 weeks? And when we saw they were asking that survey, we noticed that ourselves, we were collecting data from The Standard because we were monitoring the discussions that happened in like the chat room of The Standard. And we thought this is a wonderful opportunity for us to test if these 2 things correlate at a faster time scale and not just weeks. It's less data, of course, it's not months, but at least we have that faster resolution. And we don't have exactly daily resolution because when you ask about yesterday, it's tricky. So if you ask about yesterday at 1 a.m., it could be the 2 days ago or the last day. So there's a bit of an error in the meaning of yesterday that makes it that you can only make windows of 3 days. But when we have that 3-day rolling window, we can compare what we measure in the survey and what we measure in the text. Because it's such a pity, we didn't have time to pre-register this, so we didn't have time to adapt anything. We had the measurement already ready from another paper, and we just correlated those 2 numbers. And we got a correlation coefficient of 0.93. Which of course, part of it is because of this moving of 3 days that we cannot get rid of. But when you look at changes instead of this, still the correlation coefficient is 0.70 something. So it's actually, if you notice, it's tracking the changes pretty well. The levels, it comes from the smoothing anyway, but the changes are pretty well captured. And actually, I remember that the very last day had not been produced yet by the survey, and I saw in the text, oh, it goes down. Well, that was a bit against the trend, but well, let's see what happens. And then when we got the data from the survey, it had gone down too. So even so, the prediction happened in real time. So of course, this is in German, but trying the same kind of methods as we did, not for emotions, but for sentiment. And it was also impressive to see how this correlated, for example, with cases, coronavirus cases, and things like that. And how it also correlated with tweets. So this was the standard posts, but we also tried with Austrian tweets, and with a similar correlation, which was another kind of robustness test of the method of macroscopes. And so while working on this, I was wondering why did it work. It was working a bit better than I thought. Of course, not everything, not every possible design, but it was working. And I started to think why. And one possible explanation for the data not being representative, but still helping us to measure society, is that people are talking about emotions, but maybe not about their emotions, but emotions of others too. or about causes of emotions, that they are causing their emotions, but also cause the emotions of others around them. So people might be working as a social sensor of their environment rather than a self-report of what they feel. And in the Complexity Science Hub, where I'm also affiliated, is Mirta Galesic, that has worked a lot on the social sensing ideas, especially with survey data. And I asked her if she thought that this could be an explanation. And she threw a couple of hypotheses at me to test against the data. One was if you take people with a higher number of followers, they should be better correlated with the survey than the ones with a lower number of followers. And I thought that's counterintuitive. They should be less representative of society because they happen to be the popular ones on Twitter. But she said, no, from the social sensing hypothesis, they're better social sensors. First of all, they will have better information in their environment. And second, they will also be influencers, and they will also be affecting the emotions of others. And in that sense, if you don't think it as a isolated people, they should also be better sensors. And it actually worked. And people with a higher number of followers were better correlated with the representative survey. And other hypotheses also, like tweets with third-person pronouns will be more emotional than the ones with first-person pronouns, and that also helped. So I think that's what's happening. It's not that this is a replacement for a representative survey, but it might be working as kind of a surrogate of a survey of this kind of social sensing. And we're getting a larger sample than Twitter users, that is Twitter users and their social environment, that becomes actually more representative of the rest of the society. If you think about it, maybe most of the society, everyone has a friend that has Twitter, even if they're a minority, they're still embedded in society and they can be sensors of what happens around. So I think now one of the challenges or the opportunities will be to adapt this methodology, not to measure what people say about themselves, but what they say about the environment. And that could be a better sensor of emotions around them. Okay, and the second topic I want to introduce is the latest method we have developed to detect individual emotions from social media data. And this came from part of my frustration with the methods I applied before, because most of the time we validate them versus text that has been labeled by some people who read the text and not by the authors who express emotions. So the typical case, like the man on the left, they're trying to express their emotions online and they feel in some way. And then usually we have a mechanical Turker, like the woman on the right, that is reading the tweet and trying to guess what is the emotions that this person is expressing. We usually try to get a number of mechanical Turkers or volunteers or something to give an approximation of that feeling. But it will be better to have the assessment of the emotion or a self-report by the author of the tweet and not by someone reading the tweet. Most of the methods we have are trained against that kind of labeled data by readers and not by authors. And I wanted to see what can we do when we have data labeled by authors, especially in terms of emotion and not in terms of like a star rating from a product review or something like that. And so for that, we developed, and this was one of my long-term babies I was working on for a while, that I call LEIA, Linguistic Embeddings for the Identification of Affect, as what I think is the next stage of emotion detection on social media, in the sense that now it has been validated against self-reported emotions and not against someone else's reading of emotions. And the idea there is that we took the typical approach of having a pre-trained model versus Twitter data, and we pre-train it as a classifier with a data set from an online platform, a mobile phone platform called Vent, where people write about their emotions and they label how they feel as a way to tell people, this is how I feel and that's why I'm writing this Vent post. Let's talk about my feelings. So there we have not completely natural in the sense that it's only on this platform, but we have very good labeling of emotions by people. And there's already been some validation data studies before to check that those labels are valid and people are not joking and things like that. So we had millions of posts there, and that actually allowed us to do also one of the things I wanted to do for a while, that is not just training against that data, but also testing or evaluating the quality of the model, not only with a random leave out sample of posts, but also with a random sample of users that were not at all in the training data to test how the method generalizes across users, and also with the last 10% of the data to see how the method extrapolates over time. So there are like these three types of validations I wanted to do. And so we have 5 emotions from this labeling that also we could identify from psychological literature a priori. Angry, sad, anxious or afraid, and then 2 positive emotions, joy and affection, as kind of a socially oriented positive emotion. So we could train a model. Now with all the LLM models, this feels easier to explain. So we have a language model that is built on a transformers architecture that is learning how to classify these 5 emotions from the training data. We do it with what is called emotion-aware masking. It's a way to use word lexica in the training so that we can tell this word is in an emotion lexicon, learn it better in the fitting of the language model without the classifications yet. It's kind of a trick to make it learn emotions better. And then we have this kind of classifier that we can compare against the typical unsupervised or supervised methods and to see how well it does, first of all, in this kind of in-domain evaluation of the 3 samples I told you, but also with out-of-domain data sets from previous tasks of emotion detection on Twitter, Reddit, and even other self-reported kind of tasks. So with that, we have the whole pipeline, how to develop and test this Leia method. Thanks to this huge data set, it was possible. So we have about 9 million posts in total that we can consider. We trained with 6.3 million of them. We have about 700,000 for development, so for testing these ideas of emotion masking and so on. And then we have almost 1 million in each of these 3 test samples. And the out-of-domain data sets, so usually they're from competitions, and there's a validation or a test data set. And then we have like 5 more out-of-domain tests to try how the emotion detection works, at least in 4 out of 5 emotions. They have sadness, anger, fear, and some sort of positive and specified emotion. So how methods work, here I have a comparison between the most typical unsupervised methods like look and the NRC lexicon. So this is just word counting. And the F1 they have, again, they don't have affection, but for anger, fear, sadness, and happiness, they achieve F1, so usually something below 40%, so they're not very exciting. When you fit something on our data set, so now supervised on our own data is the red bar. This is an AI-based support vector machine, typical approach for supervised classification. Of course, it gets better in domain, like 60%. But then when we try Leia and we have our bigger methodological approach, we get pretty much to a level of already agreement among annotators if we had the readers instead of the author of the text, that is something like 0.75 or so of F1. Also across emotions and across the user, temporal and random test samples. So it generalizes well across time, people, and posts. So overall, it looks like what is the best that we could do in this particular task. Then we move to the out-of-domain datasets. And there we have these are 4 examples of them. A universal joy that is based on, I think it's Facebook data, Go Emotions from Reddit, Tech is from Twitter, and ICR is a production task. So it has annotation by the writers of posts. And here we see that fear is something a bit tricky, and maybe Leia is not doing so well. In particular, some of these data sets they have very small samples of fear. And something like a word counting method could do better because of how few tweets or few texts we have. But for the other 3 emotions, anger, happiness, and sadness, actually, Leia is pretty much the best. The both flavors we have, the base and the large one, doing the best. So again, this is out of domain, so we haven't trained at all with these tweets. And we have performances that are, again, up to 0.8 or so in ICR these days is one. It can get a bit lower in noisier situations like Twitter, but overall it works out of domain without losing that much comparatively to other methods as we had in domain. And then while working on this, of course, we have to compare with other methodologies. So in particular, I want to jump to the showdown that they call the Star Wars showdown, because the name Leia comes from a comparison between Luke and Vader as the 2 more popular methods used before in social media data analysis. LIWC is pronounced Luke, like Luke Skywalker. Then another paper was saying we have the better Luke, that is Vader. And I say we come with the best of all 3, at least for the emotion detection task. But we tried a bit. Let's try to make this into a positive negative classification task, as what Luke and Vader, or what Vader basically was promising. And let's compare the methods versus Leia, and again, outside its comfort zone. And there we see that it's not doing worse than the other methods. ICR being an easier example, of course, it does very well, but in other data sets, when we do this positive, negative, of course, there's some cases in which it's just comparable, but in several cases, it does better than methods that were developed precisely for positive and negative classification. So it was also a nice way of seeing that is adding something on top of what the other Star Wars methods were doing. And then, of course, we have to consider also GPT models. And here in domain, our dataset is a very interesting one because it's not public. You can request it from the researchers that did the paper, but ChatGPT or OpenAI doesn't have access to it. So it's good to try to make a validation. We made a zero-shot task with GPT 3.5 and GPT 4. This was a while ago. Maybe GPT 4 is better now, but it was soon after GPT 4 was released through the API. And in a zero-shot task, which is, of course, a hard task, given that ChatGPT has not been trained against that data, but people had a lot of inflated expectations on these kind of models. And in a zero-shot task, these GPT models don't do better than Leia. And this is a recurrent finding that a well-trained transformer model in domain does, of course, better than even a few-shot example case with large language models. The interesting observation is when we go into the out-of-domain datasets, in a zero-shot situation, GPT 3.5 and GPT 4 does extremely well. That's better than Leia and even too well. Like for the ICR, GPT 4 has like a 90% F1. And these datasets are publicly available, including the test data and including the labels of the test dataset. And so this is making us feel that there's a bit of a contamination of the data into the training of the GPT models, not just in the sense of it seeing the tweets on the wild, but also seeing the annotation. And the only dataset that is young enough to perhaps not being part of the training data at that point was Universal Joy, because it was really the latest dataset, and it's the one in which it does the worst compared to the others. And so it's a bit of a cautionary tale. Like if you want to compare with LLMs, you have to make sure that the data is not part of the training. And it's usually hard because we don't know what is in the training. Only when you really own the data and have never made it public is in a situation where you can really tell that you can compare, which is what happened to us. And we saw that Leia was still doing better. So we also did a bit of error analysis to see what is wrong when Leia gets it wrong. And in some cases, it's fine nuanced differences, and this might be because of the coding scheme of having to choose one emotion for a post. For example, here, Leia was predicting affection, and the true label was happiness. And these are two very positive emotions, and perhaps this person, if they had the choice to choose two moods, they might also have chosen affection. So it's not a very bad error, so to speak. Sometimes it's a type of error we noticed. But in other cases, I mean, this is not an error. The anger one is just an observation of an example where it actually worked and it got the anger right. Actually, when I saw this one for the first time from this ICR dataset, I thought it could be something like sadness. But after having been a parent for a year and a half after this, I can understand it's only angry. You get angry when your children lie to you. No? It makes more sense as a classification. But in other cases, it's very hard. So there was this one. I felt something, that's this ICR task, when I cycled down a mountain in Scotland, and Leia is predicting happiness because cycling down a mountain should be happy, but the person reported fear because cycling down a mountain can be very scary. And this is something that can also point to possible biases in the method, because if you change the word Scotland for Kashmir, it's more afraid than of Scotland, or maybe more. If you put Switzerland, it's also more afraid. Maybe the steepness of the mountain plays some sort of a role. But you see that it's kind of reading too much into details of some of the words, rather than giving us some possible distribution of possible emotions, rather than just trying to put all of its money in one particular class. You can try this if you want. The model is available in Hugging Face. You can also play on the web interface if you want to try some examples yourself. So I hope that you can use it in your research if you can. And there's a few papers reporting what I showed you. There's my eternal preprint on that validation of emotions that you can see. And the data is on a repository, so you can also test everything I was telling you there. And there's a more write-up of it that we will publish in the World Happiness Report, so more like a policy report on that particular study. But then we have like that replication we did in Austria and Leia in EPA data science that we published a few months ago. And with that, thank you very much. I hope there's a bit of time for discussion, and thanks a lot for your time.
Thank you so much.
Thank you.